So far we've seen two types of linear relations. We've expressed linear relations in the slope-intercept form, which is y equals mx plus b. We've also looked at the point-slope form, which involved both a point on the line and as well as the slope. And then finally, we're going to end with the standard or the general form of the equation over here, which is ax plus by plus c is equal to 0. And all of these here, and I'm going to underline the a, the b, and the c, these are all constants. And one thing I want you to keep in mind is that we can convert any of these three into the other form, right? They're all interchangeable. It just depends on what you're trying to do. Okay, so if we're looking at the equation here where it's written as 2x plus 4y minus 12 equals 0, and we're going to connect it over here, the constant that is in front of the x is the a, so that would be the 2. The constant in front of the y, which is 4, is your b. And then the constant that is not attached to any variable, that's the c. So if I were to ask you, what are the values of a and then b and c, well, we would say that your a value is 2, your b value is 4, and your c value is negative 12, because we can't drop that negative over here. So let's say we're asked to rearrange the equation below into slope/y-intercept form. Okay, so remember that y-intercept form is in the form of y is equal to mx plus b. And so what we're going to do is we're going to make sure that the y is on one side of the equal sign, and then everything else gets placed on the other side of the equal sign. So the strategy here is going to be pretty straightforward. We're going to rearrange the equation for y, which means we're just going to get the y by itself. And then we're going to remove any coefficient in front of y using algebra. And one thing I should say is that this over here, this part is also using algebra. So really, both steps just involve using algebra. One last piece of advice is that you should try to do the algebra in 2 steps, so move one variable at a time. So I can see here that once I divided both sides by 4 to get rid of the coefficient in front of y, everything else simplified. And what we want is the simplified version. So I'm going to rewrite this equation here as y equals negative 1/2 x plus 3, where this is going to be your m, and then that is your b. And I'm just going to circle it in orange here so we can see the final equation. Okay, we're going to convert this equation, which is already in standard form, to the slope-intercept form. And we're going to do this just like we did the first time, which is we're going to isolate for the y first, and then using 2-step algebra, get everything to the other side. Okay, so let's say we're asked to graph an equation that is in standard form. Well, it's really just an extra step. If we follow this strategy where we rewrite the equation in slope y-intercept form, then we could take that and easily graph it, because by this point we've had extensive experience in graphing equations that are already in slope y-intercept form. So the first thing we're going to do is let's convert this equation here into your slope y-intercept form. like we did previously, I'm going to start my graph at the y-intercept. Here we go. So at 2. And then we can see that the rise over the run is -1/2. So we're going to go down by 1, over by 2, and then plot the point, and then down by 1, over by 2 to plot another point. And then we usually do 3 points. Let's do one more. Down by 1, and then over by 2. And then we're going to connect these dots right here. Okay. And so this really is the equation. Although it's written like this, it's essentially the same equation as 2x plus 4y minus 8 equals 0.